All right, now we're ready for condensation. So, condensation is the opposite of evaporation. Condensation is where the gas changes to a liquid. We know in the water cycle, when that happens, it has the water vapor that's in the air, which is a gas, and as it starts to rise, it cools as the temperature gets cooler and condenses to form clouds. Now, when this gas changes to a liquid, we see it in lots of places. We see it as fog on a window, steam on a shower, water droplets on a glass of water, even clouds. So think about this. This is when it's losing its energy. Condensation happens with the cooling. It's just the opposite of evaporation. Okay, let's take a quick look at freezing. This should be a pretty easy one. Freezing is the state change of a liquid to a solid. And it's really important for you to know that water freezes at 0 degrees in Celsius and 32 degrees Fahrenheit. Well, the next thing we're going to do is we're going to take a look at the idea, why does ice float? So if you look at this picture here, we've already talked about the structure of water when it's in different states. You can see the water structure, the molecules in a liquid, tightly packed, very dense, and you can see the water as frozen, ice. When it freezes, we know that the water expands, right? The molecules expand. You can see some little holes there. Which one do you think is more dense? If you said the water, you're right. We know denser things are going to sink. Density is a measure of how solid something it is. So we know that ice floats because its molecules are less densely packed than those in liquid water. There's actually a mathematical way to figure this out. So water has a density of 1 gram per milliliter cubed. Anything that is more, has a density of more than 1 gram per milliliter cubed, is going to sink in water. Anything that is less than 1 gram per milliliter cubed is going to float in water. So go ahead, pause it if you need to, and get these measurements written down. And while you're doing that, we're going to go into a little interactive here. So you can see ice is less, which is why ice would float on water. So I'm going to take a second and get into this interactive here, which is a really cool way just to show us why ice floats. And it may take just a second. Oh, there we go. All right. So if we take a look at the liquid water molecule, we can see that the water molecule here is our oxygen, negatively charged. Here are our 2 hydrogen atoms in our molecule. We can see that the negatively charged oxygen is attracted to the positively charged hydrogen atom. Okay, so these atoms are constantly being formed and breaking up. If you take a look here, this is liquid water. So you can see all the different molecules. They're not as tightly packed. They're freely moving, okay, to fill up a space. Now, let's go up here and take a look at the molecules in frozen water or in ice. In just a second, you'll see how the ice molecules look. You'll notice some open spaces in them. You'll also notice, see if that helps it go a little bit faster, that you also notice that hexagon structure, because we know that when water gets cold, water expands, which is pushing those molecules apart, and it's going to form that hexagon structure that has the space in the end inside. Just kind of like Swiss cheese, right? It has lots of holes in it. This is the structure that we've drawn earlier and talked about. Okay, you can see how everything is connected. But then if I take it, I actually can give you a different view of that. So you can see that there's actually empty space inside, which is going to make those molecules much less dense than liquid water, which is why it will float. And if we scroll down, we can take a look at this one other way. So if you look here, here's our liquid water. The molecules are packed more tightly, okay? Here is our ice. You can see that the ice, you can still see those little holes, okay, which is going to make it less dense in that crystal structure. Oops, wrong button. Let's try this one. So, our last big idea here is that the fact that ice floats is really important to living things. Think about how nature would be changed if ice were not less dense than water. Instead of ice laying on the very top and forming on the very top of a lake or a pond, okay, that ice would sink down to the bottom. Take a second and on your paper, fill out at the bottom how the fact that ice floats is important to living things. Go ahead and pause it for a second, and then we'll come back and wrap this up. You should have probably at least 2 sentences based on what we've talked about today. Okay, so let's go ahead and review. We know that if ice sank, it would form on the bottom of the body of water as the water was cooling. So what it would do, if it froze from the bottom up, it would trap fish and it would trap other organisms in that shrinking layer of water. They wouldn't have access to the nutrients from the bottom that they needed. Okay. Ice on the top of the lake also adds that extra layer of insulation to aquatic organisms. So hopefully, by the time you finish these 2 videos, you're able to explain the different states of water, what each state looks like, and explain what makes ice float and how it's important to living things. Thanks for listening.